Okay, so we are going to do the comparison test and the limit comparison test. What you want to do is you want to think about these two balloons. So the only thing you have to pay attention to is think about one balloon inside of the other, okay? We have a balloon that has series A sub n and a balloon that has series B sub n, right? So we've got A sub n here and a way bigger balloon, B sub n. Let's say that A sub, whoops, gosh dang it. Let's say that A sub n goes to infinity. You inflate so much air in it, it blows all the way out to infinity. Wouldn't it also force B sub n to go to infinity? That's what this bottom piece is saying. That if A sub n diverges, if the small balloon blows up to infinity, well then B sub n is going to have to go to infinity. Now, similarly, if I were to let all the air out of B sub n, in other words, B sub n is going to converge to something and stop it there. Like, we'll let B sub n hold like 10 gallons of air, something like that. Well, then you know what? A sub n will be forced to converge. And that's what the first part says. So this is called the comparison test. And it's extremely helpful, and we're going to be able to use all these other tests, but particularly the p-test is what we're going to use on these. So on this first one here, I'm going to try to compare it to 1 over 2 to the n. Now I'm picking 1 over 2 to the n because it's very, very close to the original series, right? Now, which one here is bigger? Well, on the left, the denominator is bigger on the left. So therefore, the fraction on the left will be smaller, right? Because this fraction on the left, we're dividing by something that's bigger and bigger. So the one we're comparing to is larger. Now, this is equal to 1 to the n over 2 to the n, right? Which we could say is 1/2 to the n power, which converges because it's a geometric series. And in that geometric series, this r value, right? The absolute value of r is definitely less than 1 because the r is 1/2. So that series converges because it's a geometric series. Therefore, the original series converges by the comparison test. Okay. Now, let's look at the one right below this. I'm going to compare this to 1 over n to the 1/2 power, right? Now, the left-hand side denominator is larger because we're adding 5 to that. Therefore, the piece on the right is the larger piece, right? Well, let's think about it. This larger piece is on the outside of the balloon, whereas on the inside we have this 1 over 5 plus root n, right? Well, I believe this series that we're comparing to diverges by the p-test, right? Because a p-series will only converge if we are greater than 1, right? If the power is greater than 1. So this, trying to do the comparison test here, is inconclusive here. Because, the outside balloon here diverges. So if the outside balloon fills with infinite amount of air, we don't know what's going to happen to the inside of the balloon. It is not one of these two pieces that we're dealing with here. I was hoping that the thing we're comparing to that's always larger will converge. But in this case, we We can't go that route. So there must be something else we can do. And that's called the limit comparison test, okay? What the limit, and again, the word limit means we're taking the limit. The limit comparison test. So what we're going to do is the limit comparison test we will use when the situation we talked about here occurs, that it's just not going to work out, or we can't tell what's bigger and what's smaller. And what the limit comparison test says is that if that limit is a positive number and finite, in other words, finite means it's a number, right? It's not infinity. What it means is that, just like the integral test, these things go together. They'll either both converge or they will both diverge. Okay. Now, this first one here, this one, I'm going to compare it to 1 over n squared, and I think we would agree that 1 over n squared is larger. N squared converges because of the p-test, right? The power here is greater than 1. Then I could say that this original converges by the old comparison test, right? There's no need to do the limit comparison test because we knew that this piece on the right is larger and it converges. So again, I'm thinking about those two balloons, right? This 1 over n squared is the bigger balloon. It converges. Therefore, the smaller balloon has to converge, right? That's what the comparison test says. Well, let's take a look at this next one here. Well, this next one, I think I'm going to compare it to 1 over the square root of 3n. Now, this piece on the right is going to be larger because the denominator on the left is larger, so the fraction on the left is smaller. Anyway, this thing here diverges by the p-test. So if I think about my big balloons, trying to do that comparison test, the thing on the outside, right, it diverges. So we don't know what happens to the small balloon. When this occurs, hey, let's try the limit comparison test. And all that says is find the limit of n going to infinity of the original series divided by the thing we're comparing to. Okay, that's all. Now again, to do the limit test, they both had to be consumed with positive values, okay? Well, they're definitely positive values, so we're okay there. Well, this is the limit as n goes to infinity of the square root of 3n over the square root of 3n plus 1, right? That's what that simplifies to be. Now, I believe this limit turns out to equal 1 because these powers are exactly the same, right? If I look at that, it's, the root of 3n over the root of 3n. And I think those cancel, leaving an answer of 1. Now, that is a finite number, and it's positive. Therefore, these things go together. Since the thing we're comparing to diverged, that means that the original function diverges by limit comparison test. Okay. Again, we only use a limit comparison test when our direct comparison test is not working. Okay, I'm going to look at some other ones. Pause the video if you need to. Okay, so let's look at this one here. I'm going to compare it to the square root of n over n to the 4th power. Now, that I'm not sure which is, I'm not sure whether the left side or the right side is larger. I'm just too much going on here. And by the way, this thing simplifies to be 1 over n to the 3.5, right? Since we're not sure, and by the way, the thing we're comparing to converges by a p-test, right? The power is greater than 1. What we're going to do is we're going to do the limit comparison test here to see what's happening. So of the original function, okay, which is this, right? So we're taking the limit of the original function divided by what we're comparing to, right? And I think I already wrote it out wrong. It's supposed to be 1 divided by that. So we end up with n to the 3.5 times the square root of n plus 2 all over okay. So what we're really looking at in the denominator is n to the 4th, and in the numerator, I think that's going to be an n to the 4th. Hey, that gives us a positive answer that is finite, right? It's not infinity. Therefore, these things go together. So, since the thing we're comparing to converged, we will say the original series converges by the limit comparison test. Okay. Well, let's look at one last one. Oh, by the way, pause the video here if you need to look at what's going on. Let's move on to the last one here, this one. Now, I know this one, we could compare this to we could do an integral test on this, but I think I'm just going to work it out normally here. I want to compare it to 1 over n. Now, I think the right side, or the left side, is going to be larger because its numerator is a little bit larger. Let's think about our balloons here. The little balloon is this 1 over n business, right? Now we know that this 1 over n diverges, and we could say 2 different reasons. We could say it diverges by the p-test, right? Because the power is not greater than 1. We could also say it diverges because it's a harmonic series. Okay. Well, if the small balloon goes to infinity, won't the larger balloon have to go to infinity? So we would say the original series diverges by comparison test. Now, the homework tonight, you did a bunch of you're doing a bunch of problems where you're trying to figure out what you're going to compare to, and then you're going to decide whether to do the limit comparison test or the comparison test, and then see what's going on. We're going to talk about those on Tuesday, all right? And on Tuesday, we're doing our very last test. It's called the ratio test, and then we're done with these tests. Thank you very much.